Hello everyone, I am Golden Ashwini from Rohini College of Engineering and Technology, Department of Electronics and Communication Engineering. In this video, we are going to see the Dma controller. Okay, so first of all, we need to know why Dma controller are used, right? So when a bulk of data is transferred between memory and any peripheral devices. If input-output data transfer technique is used, this process takes more time as each byte of data is transferred through the CPU. If we want to transfer data at a faster rate, the CPU must be isolated and data can be transferred between memory and peripheral device directly. Okay, so this input output technique is known as a direct memory access operation. Okay. So on completion of this video, students will be able to explain what is DMA controller and what are the registers are used in the DMA controller and everything. Okay, DMA controller 8279. Sorry, this is 8257. Okay, for the application that require huge amount of data transfer to memory from a magnetic or optical disk, a dedicated hardware device called DMA controller. Okay, so DMA controller temporarily borrows the address bus, data bus, control bus from the microprocessor and transfer the data bytes directly from the disk controller to a series of memory location. Okay, some DMA devices even can do memory to memory transfer. First of all, we are going to see the DMA operation. Okay. So here we have a 4 blocks microprocessor. MP means microprocessor, otherwise we can say it is the CPU. Okay, then DMA controller, memory, then input output devices. Some of the books they mention it as peripheral devices. Okay, so from the input output devices initially that from that device which requires a data transfer between the device and the memory. Okay, should send the DMA request to the DMA controller. Okay, the DMA controller send a hold request HRQ. Okay, hold request actually line to the CPU and waits for the CPU to accept the hold acknowledgement. Okay, then the microprocessor tri-state all the address bus, data bus and control bus. Okay, the CPU relinquishes the control of the bus and acknowledges the hold input signal through hold acknowledgement output signal. Okay, so the CPU remains in the hold state. So the DMA controller becomes the master of bus. Actually, DMA controller circuit manages the switching of address, data and control buses between CPU, memory and input output devices. So HLDA, hold acknowledgement signal, is fed to the DMA controller when DMA controller receives a hold acknowledgement signal, the DMA controller take care of direct data transfer operation between memory and input output device. So the DMA controller sends back signal to the peripheral devices. Okay, so the DAC signal then which requires for DMA operation. The DMA operation can be performed by sending proper address to the memory and require control signal to the transfer of bank of address. So at the starting of the DMA operation, the DMA controller should know the starting address of the memory location, the number of bytes to be transferred and the types of data transfer from memory to input output or from input output to memory. Okay, this is DMA operation. Okay, next we can see the pin diagram of 8257 DMA controller. Okay, so 8257 is a programmable DMA controller. We already know that this is available in 40-pin dual line package. Okay, that diagram is shown in the figure. In this ground we see already that's all we know about that DRQ 0 to DRQ3. These are the 4 separate DMA request lines. So any input output devices send DMA request signal on one of the DRQ0 to DRQ3 lines. So when DRQ is high, a DMA request signal is received by the DMA controller. Among 4 DMA request lines, DRQ0 has the highest priority and DRQ3 has the lowest priority in the fixed priority mode. Okay, next one is DACK 0 to 3. Okay, these are the DMA acknowledge output lines which sends and acknowledge the signal through any one of these lines to the input-output peripheral devices. When this signal is active low, the line is acknowledges the input-output devices. Then next pin is A0 to A3. So these are the least significant address lines. A0 to A3 are bidirectional lines. In master mode, these 4 least significant memory address lines are generated by 8 to 57. Then the next A4 to A7, these are 4 most significant address lines of lower byte address generated by 8 to 57 in the master mode DMA operation. Then next one is D0 to D7. Okay, already we know that these are bidirectional data lines. These lines are used to interface CPU with the internal data bus of 8257 DMA. Then I bar OR bar. Okay, this is a bidirectional tri-state input line. Okay, so in the slave mode, IO signal is used to read the internal register of 8257 by the CPU. Then IOW bar. Okay, this is a bidirectional tri-state input line in the slave mode. So IOW is used to load the content of data lines to the upper or lower byte of a 16-bit DMA address register or terminal count register. So in the master mode, data is transferred from memory to input-output device during DMA memory read cycle. Okay, then MEMR bar. This is the memory read output signal. When this is active low, data will be read from memory during DMA read cycle. Then MEMW bar. Okay, this is write output signal. When this is active low, data will be written to the memory during DMA write cycle. Then next one is clock. Clock is applied to 8257 for internal operation of 8257. Okay, so which will be synchronized with the clock. Okay, next reset. Okay, reset signals are, we already know that is a asynchronous input signal. When this is active high, all the DME channels must be disabled, all mode register will be clear and all the control lines will be in tri-state. Then CS for chip select. If it is active low, this is an active low chip select signal which enable the 8257 for read and write operation in slave mode. Okay, so in the master mode, this is disabled. Then AEN, address enable. This is the address enable signal. When it is high, it indicates that the DMA operation will be performed. This AEN can be used to disable the data bus and the control bus driven by the processor. Then address strobe, ADS-TB, address strobe. This is output from 8 to 57 strobes. The most significant byte of the memory address generated by the DMA controller into the latches. Then TC, terminal count. This output indicates that the terminal count register content is 0. If the TC stop bit in the most set register is set, the selected channel will be automatically disabled at the end of the DMA cycle. Okay, so this pin will be activated when the 14-bit content of the terminal count register of the selected channel is equal to 0. Then mark and ready. When the mark output is 1 level, it indicates the current DMA cycle is the 128 cycle since the previous mark out. Okay, ready. It's an asynchronous input signal. Then hold request. The DMA control send the hold request as it is connected to the hold signal. input of the microprocessor. Then hold acknowledgement, this pin is connected to the hold A output of the CPU. This input is high, indicate that the microprocessor tries state all the address bus, data bus and control bus. Okay, so VCC we know that plus 5 volt and ground is, we know that it is a grounded. Okay, next we are going to see the architecture. Okay, this is the architecture. In this, it has a 4 independent channel. Okay, Dma controller. Therefore, 4 peripheral can send requests and data transfer simultaneously. Okay, so it consists of 4 DMA channels. What are the control logic of data transfer, read or write logic, and data bus buffer. Okay, first of all, we need to know the register organization. Actually, in this we are having the 4 independent DMA channels. That's are noted in the right side, CH0 to CH3. Okay, CH0 channel, CH1 channel, CH2 channel, CH3 channel. So each DMA channel of 8257 has two 16-bit registers, namely DMA address register and terminal count register. Okay, so these are also two common registers for all channels, such as mode set register and status register. So therefore, there are 10 registers of 8257. Okay, so the CPU can select any one of the 10 registers using the address line A0 to A3. This actually we have DMA address registers, terminal count registers and mode set registers. Likewise, we have registers. Then next one is data bus buffer. Okay, that is shown in the left side, data bus buffer. The 8-bit bidirectional data bus buffer is interfaced with the internal bus of 8257 and also with the external system bus. So the data bus buffer is tri-state type. Next is read or write logic. The 8257 can operate in either slave mode or master mode, right? So in the slave mode, the read or write logic accept the input output read IO bar or IO W bar control signal. So it decodes the A0 to A3 lines and either writes the content of the data bus to the addressed internal register or read the content of the selector register depend on IO W bar or IO R bar. So during the master mode operation, the read or write logic generate input output read or input output write signals to control the data flow to or from the selected peripheral devices. Okay, next one is control logic. So control unit. So control unit, the control logic unit control the sequence of DMA operation and generate the following control signals. What are that? AEN, ADSB, STB, then MEMB, then MEMW, TC and mark. Okay, this unit generate the address lines A4 to A7 in the master mode. Then the final one is priority resolver. The priority resolver resolves the priority of DMA channel of 8257 depending upon the priority, fixed priority or rotating priority. Okay, these are the explanation about the architecture. Next, the quiz question on DMA controller. So first question is, in direct memory access mode, the data transfer takes place. Options are directly, next one is indirectly, next one is directly or indirectly, then none of them mentioned. Okay, then the second question, in 8257 DMA, each of the 4 channel has, option A is a pair of 2 8-bit registers, option B a pair of 2 16-bit registers, option C 1 16-bit register, option D 1 8-bit register. Okay, if you know the answer for this quiz questions, please comment in the comment box. Okay, thanks for listening.